Imagine you are building a product where your LLM has to extract details from customer emails like name, email ID, issue type, priority, and it has to return JSON object every time reliably. But LLMs are probabilistic. It might forget to return the closing parenthesis. It might return string where you expected a number, or even it might return a preamble like, sure, here's the JSON you requested for. This is annoying in a demo, but in a production system, this can cause a bug that crashes your application. Hello everyone, welcome back to my channel. Today we are tackling two production problems. One, how to make sure that your LLM produces a reliable structured output. And second, how do we actually measure that your model is any good? So let's dive into it. So let's first understand why LLMs struggle with structure. Standard LLM generation is unconstrained. At each step, the model picks the most likely next token from its vocabulary of around 128,000 options. So JSON has strict rules, like key must be quoted, value must be of a certain type, brackets must be balanced, and comma must be in right places. The model might know JSON, like it has seen millions of JSON examples in training, but knowing the format and reliably producing it under all condition are different things. Under distribution shift or long prompts or unusual queries, the model might deviate. The solution is don't rely on the model knowing to follow the format. You can mathematically constrain what tokens it can generate. So that is called like constrained decoding. And the first one is like guided decoding that constrains the model's output to match a specified grammar or schema. So the process goes like this. Define a JSON schema. Let's say name is string, age is integer, and email is also string. During generation, maintain a parse state, a representation of where are we in the JSON structure right now. At each token step, compute which tokens are valid given in the parse state. Then fourth step is like set all other tokens logic to impossible sample like negative infinity. The model samples from only valid tokens then you update the parse state and repeat again. So for example, if the model has generated name, like the parse state knows where inside we are inside a string value for the name key. Only string content and closing quotes character are valid. When model generates the closing bracket, it's only valid if all required field have been filled. Outlines library is the most important open source guided decoding library. It converts a JSON schema into a finite state machine, efficiently computing valid next token at each step within minimal overhead. The second one is LMQL, that is a query language for LLMs that lets you write prompts with inline constraints like generate and in the quotes you say name colon str and age colon int where age is greater than 0 and age is less than 150. This is an example. So, and the third one is instructor library. It is a popular Python wrapper that retries with error feedback when model produces invalid structured output. Another technique is logit biasing. This is a simpler but less powerful form of output control. Instead of like full grammar constraint, you manually adjust logits for specific token before sampling. Common uses are forcing a binary choice. Like you want the model to output exactly yes or no. So you set logit of yes plus equal to 100 and logits of no plus equals to 100. All other values you set to negative infinity. The second common use case is preventing specific output. So you don't want the model to output a competitor's name. So you set logit with the competitor names key to negative infinity. The third one is boosting a language. For a French language application, you boost logits for French token. And finally, we have greedy force tokens, like force the model to start with a specific prefix, then generate freely. It is used in classification, like classify as, and in the bracket you add the force token like positive, negative, or neutral. So logit biasing is supported directly in OpenAI's API and most inference frameworks. It's a blunt instrument. You like use guided decoding for complex structure and logit biasing for simple constraints. Now let's we can now discuss why evaluation is hard. Like, how do you know if your LLM is good? This sounds like it should have an obvious answer. It doesn't. Like for math problems there is a clear right answer. For example, for write me a poem about autumn, what's the ground truth? For explain quantum entanglement to a 10-year-old, what's the correct output? So LLM evaluation is hard because of the open-ended outputs, no single correct answer, and second is multi-dimensional quality. That is accuracy, fluency, helpfulness, safety, which matters a lot. And the third challenge is prompt sensitivity. Like change the prompt slightly and the answer changes completely. Then we have benchmark contamination. That is, models may have seen benchmark data during training. This is also like data leakage kind of thing. And the another challenge is cost. Like human evaluation is expensive and slow. So that's why. So these are the challenges that we face during LLM evaluation. So there are certain methods, evaluation methods for like to evaluate the LLMs. The first one is automated metrics, like exact match is the output exactly equal to the ground truth. Only works for factual QA with the definitive answers. Or blue or rogue, like measure ngrams overlap with reference text. Fast but correct correlates poorly with human judgment for generative task. Then in automated metrics we have BERT score, that is semantic similarity using embeddings, better than Bluey but still limited. Then F1 on extracted spans, like for information extraction, compare extracted fields to ground truth. Then the second technique is called method is benchmarks, like standardized text sets that allow comparison across models. So we have couple of tests like MMLU, multiple choice question across 57 subjects, test broad knowledge, human eval like Python coding problem, pass metric, does the model pass unit test. GSM 8K, like grade school math word problems, test multiple step reasoning. MT bench, like multi-turn conversation benchmark, 80 carefully chosen questions. And Helm, that is holistic evaluation of language models. It has multiple scenario and multiple metrics. So here is a little warning, you can say, like leaderboard ranking can be misleading. Model may be fine-tuned specifically on benchmark distributions. So the next method will be LLM as a judge. In this, you use a strong model like GPT-4 or Claude to evaluate another model's output. And yeah, like you give the judge the question, the response, and a rubric, and ask it to score on 1 to 10 or choose between two responses. The advantage is it's cheap, scalable, correlates well with human judgment on average. But the disadvantages are like its positional bias, like it prefers first response, It has verbosity bias. It prefers longer answers and may favor models similar to itself. So there is one another technique. Before that, empty bench and chatbot arena are two use cases for LLM as judge. They use it extensively. So the another method is human evaluation, the gold standard. Like it's expensive, slow, hard to scale, but essential for final model decision, safety evaluation, and calibrating automated matrix. So chatbot arena LMSYS, like real human compared to anonymous models. 1 million plus human preferences collected. ELO based ranking is given, and it is considered the most reliable public benchmark. So that's why nowadays we are seeing like even Claude is saying that loop engineers are required. Like we need humans in the loop. So the next thing is evaluation hardness. Like running evaluations consistently across many model requires standardized tooling. Like Eleuther AI LLM evaluation harness, the most widely used open source eval framework. Like it has 200 plus task, standardized prompting, reproducible results, and used by most open source models releases. Then we have like Inspect, UK AI Safety Institute. It is more flexible eval framework, better for custom evaluation task, used for safety evaluations. Then we have Ragus, especially for retrieval augmented generation evaluation. It measures faithfulness, answers relevancy, context precision, context recall. And then we have a latency profiling tool, that is for inference optimization specifically. We measure time to first token, TTFT, how long until the first token appears, measure inter token latency, ITL, time between tokens during generation, and measure throughput, like total tokens per second across all users. And we have measure like GPU utilization. Are you actually using the hardware you are paying for? And we have discussed the techniques to use the maximum GPU utilization in our previous videos. So to give you a summary what we discussed today, structured output and evaluation are a difficult part of LLM engineering, but they are what makes a model separate that works in a demo from a model that works in a production. If you can't reliably extract structured data, you can't build a real application. If you can't evaluate your model, you can't improve it. So in the next video, we will see edge deployment. How do you run a 70 billion model on an Apple Silicon MacBook or an ARM smartphone? Thanks for watching. See you next time.